Hello, everyone. Welcome to the Construction America podcast. I'm digital media editor Warren Frey, and with me today I have
Jag Singh, nuclear lead at Stantec.
we're going to talk about small modular reactors. I hope I got the term right, because you recently spoke at a seminar about Western Canada. We'll get to that and small nuclear reactors. But first, if you could explain what they are and how they differ from, the classic reactors of yesteryear.
Yeah, essentially they're a smaller footprint type of reactor. So the nuclear energy that it produces, they can directly plug into the grid and produce the electricity for generation purposes. They can also service heavy industry. When you talk about oil and gas and mining, remote operations. So that's how they differ a little bit, because the conventional nuclear reactors typically need to be located on a big mass of water, right? So the SMRs, you see a renaissance happening right now across the world, right? SMR is a hot topic, no pun intended. And the idea is essentially get them modularized, get them built in a manufacturing assembly line type of environment, do your offsite kind of works testing and offsite commissioning, and really quickly and economically deploy them. So that's the idea behind SMRs, and they are a smaller output. They range from 100, the Arc 100, for example. Arc Clean Energy has a 100 megawatt reactor, electric, up to I think terrestrials at about 450, I believe at the minute, 450 megawatts for their integral reactor. So there's a huge range. Everything's still moving around at the minute, and there's a lot of development happening. But I'm happy to be here to talk to you. So thanks for the opportunity anyway, Warren.
And from what I've seen in the renderings, these are like small doesn't mean it's like a thing you just kind of plug it in a house or something. It's not Mr. Fusion. It's actually a plant, but it's a smaller version of these plants that we used to have.
Absolutely.
And like you said, not connected to water. So maybe you could explain the water supply part of it too.
Yeah. So the footprint goes down, right? So essentially, so you have Gen 3 SMRs at the minute. That's the BWS 300 that everybody's talking about at the minute. That's the one that's being deployed at Darlington with OPG. So that's a Gen 3 reactor. So I should explain a little bit on the technology types, right? So the Gen 3 is based on a boiling water reactor, which is, a conventional reactor technology, essentially. One thing we should also mention is, this, although it sounds all new and fresh, we've been really in industry dealing with SMRs back from the 1955, right? When we had the Nautilus, the naval reactors, they're all versions of, an SMR at the end of the day.
Something in a submarine, so, right?
Yeah, that's right. Yeah, the naval, naval purposes, maritime purposes, right? So submarines, they have an SMR in the back of them, right? When they for their propulsion purposes. Now, that's a typical Gen 3 kind of reactor, and that's it's loosely. I don't want to allocate both that and what the BWS 300 is, but the BWS 300 is based on that kind of conventional reactor. The ES BWR, they're 1.4 gigawatt scale reactor, and then the Gen 4 reactors are the more exotic ones that we're coming out with now. So I used to work for Maltex, a company called Maltex, and Maltex was one of those technology developers. And those reactors have different features, and I can give you an example. Typically, refueling takes 2 to 3 years on a conventional reactor. On an SMR like the Arc 100, I mean, they're like 15 to 20 years refueling cycles, right? Which is extraordinary. You can imagine the possibilities in remote communities and having to refuel that kind of period. That's pretty amazing. And the Maltex reactor, that's the waste burner. And what that does is it uses recycled spent nuclear fuel. So spent nuclear fuel that's lying around at sites across North America, across the world, The Maltex reactor actually uses that spent fuel in a molten salt form as a fuel. So it actually consumes waste. So we're seeing these innovations coming through with the new Gen 4 reactor. So it's important to differentiate those two things, Warren.
And also, what are some of the, these are smaller reactors, what are some of the technologies that came across recently being the last 20 years that allow for these smaller plants and more innovation that you didn't have before?
So yeah, absolutely. I mean, out here in Alberta, this is my home province. there's a need for steam generation at high temperatures, right? And what we're able to do now with some of these SMRs, and what they've been explored for, is application in those heavy industries. So the SAGD, steam assisted gravity drainage in the oil sands, for example, they need that high temperature, high pressure steam. So the applications of these SMRs are, they've been explored all over the place. And in that specific element there, once you get the benefits of a non-carbon emitting steam source like that, you start to really make those heavy industries a lot more appetizable for green purposes, right? So that's one element of it. We also have micro modular reactors that are coming out as well, but the SMRs specifically, I've got to give a shout out to MB Power here. They're visionaries when it comes to this. They're the ones that selected the Gen 4 reactors, the Moltex and the ARC, for deployment at Point La Pro. And again, that's for grid connection purposes, right? So that's for electricity supplied to the grid. So they're at the very frontier of nuclear innovation, and that the world leaders as far as I'm concerned. So we see a whole range from heavy industries here in Alberta out to New Brunswick, deployed at Point La Pro, a myriad of applications, and every day we have more.
I'm going to combine two questions together here because in a blog post you made about this subject, you cite waste, cost, and public perception are the three barriers to overcome, and those are all kind of like, perception, I guess, is what the problem is there. But also, what are the safety concerns, Lee? Because nobody ever hears about nuclear unless there's a disaster, which happens once every, 10, 15, 20 years, but it stays in the memory. So how do you get past that, and what are some safety features these things have to begin with?
Absolutely. I mean, safety is the forefront of nuclear industry, right? So if we start off with the safety piece first, the new reactors, the new technology, the innovations with, these reactors, some of them will walk away safe. Okay. So what we talk about is they actually have features within the reactor physics. I'm not going to pretend to be a reactor physicist here, right? I'm a chemical engineer, right? But what I can say is, there are features within these technology types where they have, an example is being a negative thermal reactivity coefficient, okay? Which means the hotter the reactor would get, heading towards meltdown, what would, conventionally be thought of as, catastrophic, the less reactive they become, Okay. So it actually has inherent walkaway safe features, which is amazing, right? It's absolutely amazing, and some of the reactors, they run at atmospheric pressure, right? So you don't get these big risky pressurized systems any longer. You have your primary coolant circuit as molten salt or molten metal in the cases of the advanced Gen 4 reactors. So it does away with a lot of kind of that risk and that perception of being unsafe. They're inherently safe, and then they have extra layers of features on top of that. Quite often when we talk about hierarchy of risk, we talk about eliminating the hazards, and that's essentially what they've done with these new technologies. They're absolutely eliminating the hazard at the source, So that's the defense in depth principles that we talk about, in the nuclear industry here. So it's really important to recognize that from the safety perspective. So, got a couple of questions there, and I'll start picking out one on one.
Yeah, for sure.
The waste part of it as well. I'm just going to spit out a fact here, right? If you take the whole US generation fleet over the past 60 years, the spent fuel from that entire fleet and all that power that we've had over the 60 years in the USA, all that spent fuel fits in a football stadium about, I think, 10 yards, I want to say, 5 or 10 yards deep, okay, stacked up. 80% of that is actually unused as well, about 80 to 90%, depending on the burn-up profile, but it's actually still fresh fuel, right? So only 20% of that spent fuel is considered waste when we start looking at processes like the Moltex Watts facility, where they take that spent fuel and we recognize it's not a liability anymore. We recognize it as an asset. So we can process that and we can recycle that spent nuclear fuel and extract whatever we need out of it, which is the 80% unused uranium, and turn it into new fuel. So we're seeing this huge shift in mindset as well. And once you start bringing out the facts to the surface on just the energy density versus the amount of waste it generates, I think everybody's now recognizing, look, yeah, which way do you want it? Do you want to put in all these GHGs and CO2 into the atmosphere, or do we want to control the waste in a controlled form? And again, I'd be remiss in not mentioning that nuclear is one of the only industries that has total accountability and costing for our waste in our entire nuclear fuel cycle. We're the only major energy producing sector that does that, right? So the responsibility is recognized. We understand it. We build it into our design. Even on our early designs, we consider waste decommission and post-operational clean out. So we consider all our primary waste, secondary waste, tertiary waste, and we'll never produce wastes that don't that have an orphan waste route. That's just not acceptable. So I think we're seeing a shift in that mindset and that opinion towards nuclear waste, in that, one, it's not totally seen as a liability anymore. Two, the amount of energy that we get for the very little production of waste that we actually do produce is totally worth that offset. So that's the safety piece, the waste piece, and the public perception. If I just touch on that for a second. I'm in, like I say, I'm here in Alberta, in an oil province, and my kids, they play hockey, and I go out and I talk to the local folks, and I have yet to come across anybody that's had anything negative to say about nuclear. I'm seeing such a shift in mindset. We had the SMR Canada event here last week. That was a Stantec, that was our idea. We're headquartered in Edmonton, for example, right?
Right, yeah.
Right. So, that is, again, it shows that shift in mindset. And that's what I was talking to on stage on the panel as well, was about that shift in mindset. We've got a real shift. Our Premier, Premier Smith, as was there in attendance and mentioned the backing of nuclear. Minister Nerdoff was also there, and he spoke about, on the panel as well, about the ever-changing shift and perception towards it. So we're seeing local communities, we're seeing provincial government, we're seeing oil sands companies, we're seeing everybody is now kind of talking about not if we should do it, but how quick can we do it. So that's a huge shift. I wasn't really quite expecting that when I moved over to Alberta, but it's refreshing, because we're feeling that nuclear renaissance take off again.
And so that leads to my next question, which was, you went to this, you were specifically talking about Western Canada at this event, which of course you're familiar with being in Calgary, but what are some of the benefits for Western Canada? It's like, I know Ontario is already, I don't know if it's primarily, but it's at least partially powered by nuclear power, but Western Canada certainly isn't. So besides Alberta, and there's Saskatchewan and also BC, which maybe because of our hydro, we don't need it as much, but what is the potential across the prairies, let's say, for nuclear power?
So again, I'd point to the oil sands. You've got some very power-intensive operations there, and as the pressures come down on emissions and being carbon friendly, that's obviously a huge draw. If we can get an SMR that's, for example, an arc reactor that can produce that high temperature steam, which it can, and only needs to be refueled every 15 to 20 years, which is amazing, then specifically that plugs straight into the oil sands industry, right? That's just an example. I'm not saying that is the technology, but that's an example, right? We also heard, just teeing away from SMRs a little, we did hear Minister Nerdoff also in a CBC News article mention the consideration of conventional nuclear power here in Alberta as well, right? So nothing's off the table as those pressures arise. And it's not just pressures on emissions. We're talking about pressures of energy security. Okay. So a good energy mix leads to energy security. We need a bit of oil and gas. We need a bit of nuclear. We need to get those energy mix correct, so that we're not teetering on blackouts. It was only January when we were getting emergency alert messages, right?
I remember that.
Yeah. It wasn't too long ago. So, I think it's absolutely recognized as the way to go. So Alberta, and Western provinces, Saskatchewan,
Mhm.
they're going down their own nuclear journey, and they're doing an amazing job. SaskPower as a utility are really leading that charge. And they've got a great team there, and I'm hoping Alberta can just replicate. And we're cousins at the end of the day in terms of provinces, aren't we? Right? So MB Power, SaskPower, and Alberta, government, we start working together, and it's going to happen. It has to happen, right? It seems to be one of the only ways that we can really resolve the energy grid situation, right? So again, heavy industry, conventional electricity production, they're the two main key offerings out for here in Western Canada. We should embrace it.
And finally, you wrote this blog post that I mentioned. Maybe you could point people towards it, because you go to a way deeper dive there than you have here, which more detail, because we could get into obviously in an interview format. So if you'd like to point people at that.
Yeah, I had a blog, and this was, I'd encourage people to go ahead and read that, stantec.com. Be able to find the blog on SMR. So, key points in there, and this is a series, by the way. This is not just a one-off. There's going to be a series of these blogs coming out on the potential of nuclear and SMRs, right? We covered the waste piece. The one bit we haven't really covered, which I went into in that article, was the economic benefits, right? So in many industries, you look at overnight costs and things like that. You look at capex and a lot of people get frightened, right? But when you get to nuclear plant, it starts making sense in terms of value proposition when we're looking at an amortization period. So you look at the levelized cost for electricity over an amortization period of 60 years or whatever it is, and very quickly starts making sense, right? So we're right in that $50 to $60 per megawatt hour range, and that's competitive. That is totally competitive with all the other energy forms, right? However, what you do also get with that is stable baseload, right? It's not intermittent supply, that's stable, guaranteed baseload. And you get, quite often you have plant lifetime extensions. We're seeing that with Diablo Canyon down in California. We've seen it with Palisades. We're seeing it across the British fleet as well. We have plant lifetime extensions, so they can go on and on and on. So the cost economic benefit of it is something that everyone wants to focus on the technology side and the physics side, and but when you start looking at economics, it also is hard to argue with, right? It's very difficult to argue against it. So the other thing that's different to conventional plants is the big builds that you usually have in a conventional reactor. They have a history of going a little bit over budget, right, and a little bit over schedule, okay, to say the least. But the modular capacity, SMR, small modular reactor, the modular piece of that puts it into really think of a manufacturing line. Think of something like that, right? Once you get your first of a kind done and you start moving on to your nth of a kinds, and you build that LFE back in, you can do modular fabrication, modular construction. And a key point I really want to make here is most of the plant that we're talking about, I know I did the technical economic feasibility study for Maltex. Most of the plant we talk about is actually at TRL level 9 or up there in that range. It's operable, it's operational on sites all over the world. We've got huge learning, huge history. It's the core bit, that black box around that nuclear island. That's the bit where we have those nuances and technology development. So the point is, once we get that solved and we get the first of a kinds built, we can move to that modular build, that modular fabrication. Do you do your offsite testing, do your offsite acceptance, all the tests and qualification that you need to do, get it on site, get it hooked up, get it inactively commissioned, get it actively commissioned, and then get it operable. And it is supposed to be as seamless as that. That's one of the huge advantages of small modular reactors, right?
Okay, great. Thanks for joining us today, Jag.
Yeah, no problem at all. Thank you.
And that's it for this episode of the Construction Record Podcast. You can hear us on Spotify, Apple Music, and Amazon Music, as well as on the Journal of Commerce and Daily Commercial News websites and the constructionrecord.libsyn.com. Thanks for listening.